Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. A hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he's doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge here. They're not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned lot of from this. I gained the more knowledge from here. And thank you for XL for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic.
Yeah, hello guys, good evening. I hope I'm audible and the screen sharing is also working. Give a thumbs up in the chat box and we will get started. Yes, they. Good evening, Dinesh. Done, done, done. Good. Good evening, Pavan. Good evening, Kushi. Right, so see, we were going through some stack related questions. Okay, so that's what we were doing in our previous session. Let's continue that. Let's open lead code again and let's solve our last question that we have discussed, because if there are any other queries about it, or if there was any network issue that would have been completed. So let's see what's the last question we have completed. That's valid parenthesis. Yeah, I think, yeah, we have done it in normal code editor. Okay. Good evening. Good evening. Now see. Okay. Let's go a pretty quick recap about it. So whatever code that we have written here, right? It is to convert infix vector into postfix form. Okay. Converting infix to postfix. Now, how to do that? We have 5 single steps. Okay. First, if you are giving me an opening parenthesis, let me paste it here. Maybe better to explain it without writing it. Okay. We are going to access each and every character in our expression. If it is an opening bracket, we need to push it. Okay. If it is a closing bracket, we need to pop all the elements until the stack becomes empty, or until you come across an opening bracket. Okay. Once you come across an opening bracket, you have to pop that opening bracket as well. Now, if you are coming across an operator, plus, minus, float division, asterisk, and we have XOR here acting as power. Okay. Whenever you come across an operator, you need to pop all the elements until the stack becomes empty, or until you come across an opening, or until you come across a lower precedence operator. Now, how we are checking that precedence or priority? I have defined a very simple function where priority of plus and minus will be returned as 1, asterisk and division will be returned as 2, and power will be returned as 3. So that's how I'm checking. Until I satisfy one of these, it will keep on popping everything, and ultimately we need to push the operator as well. That's what we have to do. If it's not an opening or a closing or an operator, then definitely it's an operand. I just need to add it to the postfix expression. Okay, so that's what. And once we are done, the last step. Okay, if you still have any other operators in your stack, you need to pop them as well and add them into your postfix vector. Ultimately you will be able to get the output. Okay, that's it. That's how simple it is, right? So this is the last question that we have seen. Now let's jump back. Let's open stack. Let's solve one more question related to it. Okay, or maybe I'll show that to you in the presentation itself. So let's see. Okay, right. So now see here. I'll just show that to you with a simple expression I have here. Now the next question that we are going to deal with is okay, evaluating postfix expression. So we have converted a infix expression into postfix expression. Let us see how to evaluate a postfix expression as well. Okay, if you look at the first picture that we have here. Okay, so like if you look at the first line here, not the picture, if you look at the first line that we have here, so what we are doing there, you see we have a postfix expression. The expression is in this manner. We have 2 space 10 we have space plus, we have space 9, we have space 6, we have space minus. Now, why I'm reading out about the space? Because you see, until and unless we have a space, we will not be able to divide. Okay, divide the other operands as well. So that's why space is important. So they will be giving you an expression separated with spaces only. Okay, so that spaces you need to take them. This is considered as an operand, operator, operator, operator. That's it. Okay. If you look at its normal form, this is how it looks like. So 2 plus 10, that is 12. 12 divided by 9 minus 3, that is going to be 3. 3 ones are, 3 fours are. So the answer will be 4, as you can see here, right? So given a postfix expression, we need to evaluate it. Okay, we need to evaluate it. And the steps are pretty simple. I'll give you two simple steps. First step, okay. If you are getting an operand, you simply need to push it into stack. Second one, if you get an operator, first thing that you need to do is you need to pop two elements. Okay, so pop two elements. Done. Now the next thing is, second popped element, you need to place the operator here, and first popped element, whatever the result that you are getting, okay, push the result into stack. Okay, so if you are getting an operand, push it into the stack. If you are getting an operator, pop two elements, perform pop 2, operator pop 1. Okay, then push the result into the stack as well. So this is what you have to do. Now let's look how it generally works. Okay, so let me just clear all these drawings here. Now see here, we got the same expression here. So what do we have to do is, we are getting 2. So what should we do if I get 2? Push it. I'm getting 10. What should we do? Push it. Now we are getting an operator. What should you do? Pop two elements. So what is the first popped element? First popped element is 10. Second popped element is 2. So pop 2, what is the operator? Plus pop 1. So what is pop 1? That is 10. Pop 2 is 2. So 2 plus 10, you have to do 12. And what do you have to do again? Push. Okay, push it into the stack. Now, why do we have to do it in the same order? Whenever you are having subtraction, okay, you will be having that change of sign. So this is very important for us to do it in this manner. Second popped element, operation, first popped element. Then you have to push that result back. Okay. Now you see we have 9 here, 9 is pushed. We have 6 here, 6 is also pushed. Now we are getting minus. Minus means pop two elements. 6 is the first popped element. 9 is the second popped element. Perform the subtraction operation in between them. 9 minus 6, you will be getting 3. Now push it back into the stack. Okay. Same thing, same operations you have to do. Okay. So what did I tell you? First thing, operand means push. Okay. Second, operator means pop 2, operation pop 1. Okay, and then push. You need to keep on doing this. For example, we have pushed 3 again. So 3 and 12. What's the next one we have? That is division. So operator, so pop 2 elements. First popped element is 3. Second popped element is 12. Pop 2, operation pop 1. What is the result? 4. Push it back. Okay. Now do we have any other operations, that any other characters that is left? No. Once your input runs out, your stack will only have one single value, that is nothing but the final result. So the answer is 4. Okay. That's what we have to do. The instructions are pretty clear. Okay. So let's go ahead. We have a question in lead code related to this. Let's go through that. Let's complete it. Okay. Now see here. Where do we have? Yes. So evaluate, or postfix, we'll say. Postfix. Evaluate postfix expression. Yes, you see, question number 150, evaluate a reverse Polish notation we have. Okay, this is the question. This is the question. Right, so yesterday you have seen me using, okay, stack implementation. We have used push, we have used pop, nothing but append and pop in order to perform basic operations. This is a medium level question, but not that much medium. You can also see the acceptance rate, 57% it is. Okay, they are telling that, okay, we have a length of up to 10 to the power of 4 minimum. I'll be giving you one character here, done. And whenever you are accessing something, it will be either plus or minus or asterisk or division. You will be having one of these four operations and an integer in the range of minus 200 to plus 200. So that's about the constraints. And you see here what they are giving us is they are giving us the tokens as a list of strings. You say they are giving us it as a list of strings. So every single character, every single value that you want, either operand or operator, will be a string. We have to convert that into integer if it is an operand, okay, for evaluation, for calculation of plus, minus and all. If it is an operator, we need to go with its equivalent symbol, okay. And if you go through the entire question here, they have given you a little idea about what is meant by reverse Polish notation. That's fine. And valid expressions they have given. That's fine. And division will between two integers will always tunicode towards 0. Means they are telling that this is going to be floor division. Okay, floor division. And you don't even have to check the division by 0. Okay, that error handling you don't have to do. They will not be dividing anything by 0. And the input will present a valid arithmetic expression. You don't even have to check for invalid input as well. Input will be valid. There will be no division by 0 in it. Okay, and whenever you're doing division, you need to go with floor division. There should not be a floating point value. And answer for all intermediate calculations. You might wonder, sir, why did they give this one? Because in other languages, C language and Java, integer has a range. Integer is fixed. Okay, if you go beyond that, you need to go with long int also. Okay, so in order to give you that clarity, they're telling you whatever intermediate calculations I have, they can be happily done in 32-bit integer. That's about the question they have given. We need to evaluate that expression and we need to return an integer. Okay, that is the final value of that expression value. Done. They are giving us a list of strings, right? So let's quickly jump here. Okay, let's see the solution of it. I do have a presentation for that, but I did not check it much. So let's see if it is of any use for us. Done. So question number 150, that is evaluating reverse Polish notation that we have done. So see this one. You're given a string, all this blah blah. We have already talked about it. Okay. These are the sample inputs, outputs. That's fine. Now, let's see the implementation in Python. Okay. See, this is the string that we have. 4, 13, 5, floor division and plus. Now, initially we are taking our stack as empty. Okay, every time you need to visualize this or you need to do this on a piece of paper. That's why I'm showing this visualization. Until and unless you do this, you'll never be able to understand everything fully. So that's the main concept of doing this again and again. Okay, so I hope you are getting that point at least, right? Now see, stack is empty for C in tokens. Okay, we are accessing the first one, that is 4 we have. So is 4 equivalent to plus? No. Is 4 equivalent to minus? No. Is 4 equivalent to asterisk? No. Is floor equivalent to division? No. Else, if it is not any of these 4 operations, they have clearly mentioned that either you will be having these 4 operators or you will be having an integer value from minus 200 to plus 200. If it is not any of these 4, it will be an integer. It is an operand, okay, from minus 200 to plus 200. Okay, Since they are giving it as a string, I need to convert that into integer, then I need to append it into my stack, then I need to push it. Okay, so I'm converting into integer, then I am pushing it. So I've pushed it into my stack. Done. Very well done. Now, one iteration, going into the next iteration, I'm accessing 13 this time. Okay, it's not equal to plus, it's not equal to minus, it's not equal to asterisk, it's not equal to division as well. Okay, none of these operations, it's an integer. So again, I need to push it into the stack. So how am I pushing it? Again, same thing, convert that into integer, then append it. Okay, fine. I'm using an array as a stack. We have seen this plenty of times by now. None. Now see the next one. Again, same thing. 5 we have. None of these 4 operations will be satisfied. So it will be again pushed into the stack. Perfect. Perfect. Now we have division. Okay. So is it equal to plus? No. Minus? No. Asterisk? No. Is it equal to division? Yes, it is equal to division. Now what did I tell you? Whenever you are getting an operator, you need to pop 2 elements. Okay. So first element and second element. You see here we are popping 2 elements. We'll be having the second popped element and the first popped element. So I think they have given it in reverse order. But anyway, okay. So we need to perform that operation there, and it should be an integer value. It should not be a floating point value. Double forward slash you can happily do, or you can even do single forward slash in other languages and convert that into integer. Whatever the result that you are getting, you need to again push it back into the stack. Okay. So once it is pushed, so what do you have to do again? Again, you see we are getting an operator. Again, pop 2 elements, perform addition. Okay, with those 2 popped elements, right? After performing addition, again, you need to push it back into the stack. Now, if you end up with no other values in tokens, that's it. So stack will only have one more value. You simply have to return it. So if you are returning it, the answer would be 6 for it. Okay, might be a small error in the animation, but anyway, I hope that is fine. So you will be able to understand it. Now, process is pretty simple. Let's get started. So here I'll be taking a stack. Let me zoom in a little bit. Okay. Let me zoom in and I'll write it in comments here, the steps that you need to remember. First step, that is operator or operand. First, let's write operand. Operand means, okay, push into stack. Second, operator means pop 2, operation, pop 1, second, push result into stack. That's it. Okay. Now we have tokens. I'll access a token in it. So for character in tokens, we have if the character is equal to plus. Okay. For now, I'll be writing it as pass. If the character is equal to minus. For now, I'll be writing it as pass. If the character is equal to asterisk. Okay. For now, let's write it pass. If the character is equal to division. Okay. Is equal to division means again. For now, let me skip it. If it's not any of the 4 operators above, okay, since they have clearly mentioned, you will be having only these 4 operators. If it is not any of the 4 operators above, then happily we can stop our operations and we can push it as an operand. That's what. Else, we need to push it into our stack. So since you already know it is a string, it has to be converted into an integer. So we have our stack. No, we don't have our stack. Let's take a stack. So stack equal to empty. So here I'll go with stack dot append of int of ch. So that character that we are accessing, okay, the string will be converted into an integer, will be pushed into the stack. Okay. So what if it is a plus? What if it is a minus? Let's do the calculation here. So pop2 is equal to, or pop1, let's do it. So P1 is equal to stack dot pop. Okay, maybe yeah, we'll get an issue. We have to do this inside the array only. Okay, because if you get an plus or minus, then only you have to pop something. Okay, otherwise we cannot pop from empty. Na? Since they have given me this is going to be a valid arithmetic expression, I don't even have to check if I'm popping from empty or not. Okay, because it's a valid one. So definitely if you are popping, there would be an element. So you don't even have to worry about it. So yeah, pop two elements. We just need to go with the addition operation for it and push it back into the stack again. So you see, when I push elements into the stack, they will be integers. So when I'm popping them, I don't have to convert them into integers again. I can happily perform the operation and push it back. So what is the result? Result is equal to P2 plus P1. Okay, I need to append this result. Stack dot append of result. Okay. Why P2 plus P1? Why not P1 plus P2? Both are same, but this will make you understand. We need to do second popped element operation, first popped element. That's why I'm writing everything in a separate line neatly. So let's do this one here. So here it should be minus. Okay. And let's do this one. Asterisk is also same. You can perform asterisk in any way. P1 into P2 or P2 into P1. That's same. Now coming to division, you see it's going to be floor division. Okay, so double forward slash and append that result. Now once you perform all of it and once everything is completed, when you come out of the loop, okay, you will only have one value inside stack, that is nothing but the result. So return stack of 0. Okay, stack will be only left with one single value, and that is going to be the final value of this expression. So what did we do? Operand, we are pushing. Operator, popping two elements, performing the operation, pushing it back into the result. Okay, let's click on run and then let's submit it. Okay, let's click on run. Let's see, for two test cases we got it right. For the last one we are getting it wrong. There might be a small issue somewhere. Let's check it out. These two are okay. For the third one we are not getting it correct, right? It's a pretty big expression actually, but maybe I did this pop to pop one wrong. Popped one, popped two. Mm-hmm. Let's see. Whenever you are getting anything wrong, the best thing is to just trace it manually. Okay, then you will be able to figure out what happened there. Let's see what went wrong here. Okay, so I'm taking my digital pad here. Now let's say we have a stack. So we got 10, pushed it, we got 6, pushed it, we got 9, pushed it, we got 3, pushed it, we got plus. So pop two elements, perform addition, then push it back again. So here popped 9, popped 3. So we have to perform plus operation. 9 plus 3 is going to be 12. Pushed it. Now we got minus 11. So minus 11 is again pushed into the stack. Now what do we have to do? We got asterisk again. So asterisk. So we need to multiply both of those values and push it back. So 12 11s will be getting minus 132. Okay. Minus 132. Now again division we got. So this is pop 2 divided by pop 1 minus 132. Maybe it's the other way around. Maybe it's not. Mm, will we maybe ending up with 0? Let's remove this part. Let's say we got ended up with 0.
got 0 and 10. We have multiplied both of them, then you will be getting 0. Then you have 17 and 17 plus. Okay, 0 we have. Okay, it's 22 only, but we are getting 12. Done, done. So there is some sort of error with our code. Let's check it out. Let me try and print my stack at every instance, so I'll be able to check that out as well. Okay, so let me run this. I'll be able to identify what's going wrong. So 10, 6, 9, 3 is there, done. We got plus, so 9 and 3 has been added. It's got into it. And now 6 divided by minus 132. Okay, I got the issue. Okay. You see, I think maybe I have pointed it out or not, but let me cut it out. You see, in Python, whenever you are going with negative values division, okay, so let me show you what's happened there. So print what is 10 divided by 2. Okay, 10 divided by 2 is 5.0. Okay, so what is 10 divided by 3? 10 divided by 3, that is 3.333 something. So now what about 10 floor divided by 2? 10 floor divided by 3, that will be 5 and 3, right? Now check out this one. What about minus 10 divided by 2 and minus 10 divided by 3? Is it going to be 5, 3? No. Okay. It's going to be minus 5 and minus 4. So whenever you are going with floor division for a negative value, it is going to go with the next negative value. It will not be giving you minus 3. It will be giving you minus 4. So this is an issue for us. Okay. Let's try to avoid it. So whenever we are performing any divisions with negative values, let's do one thing. Let's convert them into positive integers. Then we will make it as negative. Okay. So this is going to be better if we do it that way. So let's do that. So I'll see if P1 is less than 0. Okay, if P1 is less than 0, or how should I write it? Let's check it out. P1 we have, P2 we have. If we multiply both of them, then that's going to be good only. And P2 is greater than 0. Okay. Since they have given you the issue that you will never be having division by 0, so that's completely fine. If P1 is less than 0 and P2 is greater than 0, we'll take the sign, let's keep the sign as positive. Sign equal to +1, or you can simply keep it 1. Okay. We'll make this sign as -1. Okay. Sign equal to -1, or sign equal to -1. P1 is equal to minus of P1 we will do. Now why I'm writing this? I'm just converting that number into positive number. I'm remembering ultimately I need to send it as a negative number only. Okay. Elif, if that's not the case, I'll go with elif P1 greater than 0 and P2 less than 0. Okay. If P2 is negative. Now why I'm writing it in this manner, if P1, P2 both are negatives, then the output will be positive only. I don't even have to worry about it. So it will cancel out each other, you see. -10, -3, most probably will get 3 only. So it's not a problem for me. It is a problem if one of them is negative, you see. If we are having in this manner, then it's a problem for me. So -10 divided by 3 or 10 divided by 3, I'm not going to get 3. Okay. Even we can do one more thing as well, but you can check if it is it's not a, what you say, if it's negative value and it's not perfectly divisible, then you can subtract minus from it, or you can even write this base core logic as well. That will be fine. So sine is equal to -1 I'll do. Now P2 equal to minus of P2 will write, right, done. Now everything will become positive. Now when I am adding it, I need to multiply it with sign. So if the sign is turned, if the sign is originally positive, it will stay positive only. If you get any negative number, then we are changing its sign, and we are changing its sign here as well. So ultimately when I'm pushing it, I'm making that sign positive. So let's see if this works or if we have to do some other changes in it. Let's check it out. Now you see third test case is also fine. So everything is fine. Okay, so where was that error? When I was dividing, okay, 6 divided by -132, I'm getting an error. This is one of the most common errors when you come across with Python. So that's fine. Now let's click on submit. Let's see if it satisfies for all the other hidden test cases or not. For one single input also we have completed it. Okay, so output time exceeded by, because you see I'm using a small print statement, so it is gonna take some time to print that as well. So let's remove it. Most of the other times it's fine only, so don't even have to worry about it. 19 of 22 pass, so if you submit it, this will be absolutely fine. So it will not take much time. Okay, logic is correct, so you don't have to worry about it. When you keep that print statement, it will take some time to display all of those operations. So that's why I got output time limit exceeded. Now let's submit it again. Now it's 3 millisecond only. You can submit it one more time. Okay, this is 0 millisecond, 100% it is. That's it. Now let's see if we can solve it in any other way. So we have stack, we have array math. There is one more function. Let me first try it out, then I'll show that if it's possible. I'm cutting it. So what we'll do is, let us join everything. So result is equal to dot join of tokens. Okay. So we can go with return eval of result. Let's see if this works or not. Invalid syntax. Okay. Postfix expression will not be able to write. So that didn't work. So we generally have an eval function to evaluate an expression. So I've joined all those characters into a single string. I tried to use eval, but it did not work. So this is it. This is about, okay, evaluating postfix expression by using stack. Okay. And this is a medium level question. And why do you have the acceptance rate so low? Because people tend to forget the order they have to do, okay, division and subtraction. So because of that, you will be having that negative values. Okay, so that's one thing. And the second thing is in Python, if you are doing it, this issue is only faced in Python, not other languages. So if you are doing this in Python, you need to take care about that sign as well. Okay. That's it. So I'll copy this entire thing. I'll paste it inside the code editor so that you can take a screenshot and do this later on. Okay. So that's it. This is the question that we have solved. Let me split the screen into two halves so that you can take a screenshot of it. Okay. Done. That's it. That's it. I hope everything is visible. Do take a screenshot of it. Do take a screenshot of it. Okay. This is evaluating reverse polish notation. Okay. That is nothing but that postfix form. Okay. Reverse polish notation it is. Reverse polish notation it is. Done. Understood this one? Any doubts in this one? Can we carry on with the next one? Understood this? Any doubts in this? Understood this one? Any doubts in this one? Right? So simple stack operations these are, but remember stack is very important. Okay. So moving forward, when you go with algorithms and all, so stack is very important. Okay, sign logic one. So what I am doing is, okay, So yeah, and same thing, a very basic thing actually. Whenever you are unable to understand any piece of code, okay, since we are not going to continue these sessions forever, we have, I think, 3 more sessions remaining after this. This is a pro tip. I hope everyone will follow this. You see, I never had a DSA lecturer. Okay. If you had anyone teaching you, then maybe I may not have ended up with this much clarity. It took me a lot of time to figure out everything on my own, but that gave me a superpower. That superpower is you give me any technology, you give me any question. It may not be possible that I'll be able to come up with every single answer, but I'll search every answer. It can take me 1 day, 2 days also, but I'll make myself understand. So I've mastered that way of self-learning. Okay, so that's one thing I would like you to understand pretty much. Whenever you're unable to understand any piece of code, do this small thing. Let's say we are getting the first stack popped value is 10. The second stack popped value is -3. Okay. When I perform 10 divided by -3, I should be getting -3, but I'm getting -4. So that is going to mess with all the calculations that we are having. So in order to make it normal, so what I wanted to do was I'll perform 10 divided by 3. Okay. The answer will be equal to 3 only. Because 10 divided by -3 was there, I will be returning this as -3. That's what. So I decided to turn everything into positive, perform division as positive, then return that as negative only. So this is where I'm checking it. I'm checking if 10 is less than 0 and -3 is greater than 0. No. So if is not true, I'll come to else part. I'll check if 10 is greater than 0. Yes. And -3 is less than 0. Yes. So now then what I did, sign initially was +1. I have converted sign into -1. Now P2 is equal to, so what is P2? P2 is equal to actually -3. So -3 has been multiplied with minus again. So -3 became +3. Okay. So now I'm performing P2 divided by P1. So what is P2 divided by P1? P2 is 3. Okay. And sorry, P1 is 10. So sorry, I was writing 10 divided by 3 here. But anyway, 3 divided by 10. Whatever the result that you are getting, you will again multiply that with subtraction because sign has been converted into -1. If none of the values are negative, if both are negative, then the output will be positive only. I don't even have to check. I only have to check if either P2 is negative or P1 is negative. The other one should be positive only. Then I've converted the sign into positive. Then when I'm multiplying, I'm returning it with its original sign. If it is positive, it's gonna return as positive. If it's negative, it's gonna return as negative. That's how it will be. Okay, done. That's it. That's about this part. So whenever you are unable to understand any piece of code, you can do a simple tracing there. Then you will understand how it thinks, how it works, right? That's it. That's about reverse Polish notation. Let's see if we have any similar questions related to this. Okay, we have basic calculator, we have add expressions. These are hard level questions. So you see, you can happily solve easy and medium level questions. Hard, you have to barely touch them. Okay, not required, not that much required to get into product based companies. So I would not recommend you going with any hard level questions also, right? Just a second. Done. So let's go back to stack list, then we can see what other questions we can solve. Okay. Came back here, searching for stacks. Sorry. We have the category now. Where is, yeah, stack 177 questions. Okay. Right. So valid parenthesis is done. Next, we did not talk about queues, implement queues using stacks. Palindrome linker list also uses stack only. We can also use that. So, or you can even do that linker list one on your own easily. Let's go with next greater element one. Okay, this is important. So let's go with this. For this, I'll be giving you enough time. Okay, I want you to solve a question fully. We did not have that since a long time. You see, we have this question. You can also open this in your own laptop and check it out. Okay, so I'll be giving you 4 minutes. I'll be giving you 4 minutes. That should be more than good enough for you. So your time starts now. It's an easy level question. Go through the constraints as well. 75% acceptance rate, which is very high. So, and I want you to solve it in the stack way by using a stack. You are learning stack, so you have to apply stack in order to solve your questions. Okay, it's very easy to solve it in normal way. So do it in stack way. That's what I want. Okay. And your time started, you have 3.5 minutes. You have 3.5 minutes. So go through it, complete it as stack. Right, I hope you are going through the question. Here are the constraints. Okay. Done. I'm waiting for some approaches. Right, your time's almost up. Okay. Got one answer, I guess. Oh, no. Stack dot push off element equal to 1. No, will not work. Right, so maybe this one is a little bit difficult for you. Let's see if I have it. Yeah, next greater element. Done. So next greater element, one this is, okay. You guys can do the second part of it. You see, as they are telling, the next greater element of some element x in arrays in an array is the first greater element that is to the right of the x in the same array. Okay, so next greater element is in the sense the terminology might look a bit complex for you, but it's quite simple if you understand the first line. Whatever element that you are getting after it, which is greater than the current element, that's what we call next greater element. That's it. That's how simple it is. Okay, and we will be given two distinct zero integer arrays. Distinct in the sense you'll not be having any repeated values. Okay, that's fine. Everything they mention in the question is of some use, so we need to make sense out of it. Now, when you will be able to get this much idea, when you keep on solving daily, if you solve two questions, three questions, when you solve all these standard questions, that will be it. You will be able to do all of that. Okay. You're given two distinct zero indexed integer arrays, nums1 and nums2, where nums1 is a subset of nums2. Okay. So all the values of nums1 will be present in nums2, they are saying. And for each 0 less than or equal to I less than or equal to nums1 dot length. For every index, okay, we need to find an index such that where the element of both of the arrays is going to be equal, and we need to determine the next greater element. Okay, you need to return an array of all the answers which are consisting the next greater element such that okay, they match the description above. So if you are still feeling confused about it, yes, it happens. Okay, so don't worry about it. 70% of the time I never understand the given question. Okay, so what do we have to do? We just need to simply go through the sample input output, then again come back. So see here, we are having 4. Okay, so let me change the color. We are having 4, we are having 1, we are having 2. Do you see any repeated numbers here or here? No. They said it's distinct. Okay. Means no repeated values you will be able to see. Fine, done. Now why they told you distinct? There is a reason. We will be using a hash map as well. That's right. Okay. Hash map in the sense dictionary we will use or some other thing. So dictionary is better. Mapping, no? So that's right. Table means you can even go with array. Now see what's next. What can we do next? You see, when I take 4, you say this is where 4 is located. Do I have any other element which is greater than 4 to the right side of it? No. If we don't have one, then -1. Okay. If I take 1, you see 1 is present here. Do we have any other element which is greater than 1? Yes, we have 3 elements. 3 we have, 4 we have, 2 we have. All of them are bigger. Now what's the question? We need next greatest element. So what is the next greatest element after 1? That is 3. So that is why 3 we have. Now when you take 2, okay. Now when we go through all the elements, where is 2? Here. Do we have any other element after it? No. So no next greater element. So -1 you will be having. Okay. That's it. So we just need to return an array of size nums1, okay, with the next greater elements for all those values. That's what they wanted us in the question. That's what they wanted us in the question. Okay. You can see the second one as well. We have 2, 4, we have 1, 2, 3, 4. Nums1 is a subset of nums2, means all the elements of nums1 will be present in nums2. And you'll not be having any repeated values. So you're safe to take them as keys and all in your mapping. Okay. And yeah, this is the constraint. You will be having at least one element up to 1000. And the values inside your array can be from 0 to 10 to the power of 4. And all integers in nums1 and nums2 are unique. And all integers of nums1 will appear in nums2. It is a subset of it. Okay. So these are all the constraints. They will be giving you a question, okay, only for you to solve it. You will be having all the hints in the question. Once you go through each and everything, you will be able to understand. We only have the implementation in Java. Let's see if we have it in Python. Where is it? Yeah, implementation in Python we got. Yeah, see, let us say I have these two arrays, nums1 I have, nums2 I have. You can clearly see nums1 is a subset of nums2. We have 6, 1, 9, 3 in nums1. Nums2 clearly contains 6, 1, and 9, 3. Okay. And now if I come up with the next greater element after 6, that is 5. Next greater element after 1, that is 3. Next greater element after 9. Okay. Do I have anything after 9? Let me check it out. Did I write it correct? After 6, sorry, I wrote it wrong. Yeah. Is it 6 we have? What is the next greater element after 6, which is greater than 6? You see, we have 8. Okay, so answer is 8. Next 1 we have, next greater element after 1 is 3. Next greater element after 9, we don't have anything, so minus 1. Next greater element after 3 is 8 again, so we'll be having this answer. Okay, 8, 3, minus 1 and 8. Okay, now let's see how we are able to come up with the answer for it. Let's check the animation part for it. This is also a part of monotonic queue. Okay, let me show that to you. If you open the topics, you will be able to see monotonic queue as well. Okay, kind of like not that much different. It's easy only. So hash table, as I said, hash map we will be using. Hash table, hash map, the name is interchangeable because they do the same. Mapping will give you it in one single operation. Table means we need to search, but it's the same. The topic is the same. Array, we are using stack, we are using monotonic stack. So that's why it's labeled with all of this. Let's continue. Let's close these things. These are not needed. 150 is completed. Yeah. Let's present from this one. Okay. Nums1 we have, nums2 we have. Okay. Now I'll be taking a dictionary, a mapping structure, hash map I'll take. Okay. I'll be mapping a key with a value. Why did they mention everything as unique? Because they wanted us to use map there. Key values cannot be duplicates. Na? That's what they are hinting there. Okay. So keys cannot be duplicates of each other. So key should be unique only. That's why they gave us unique. Done. Now stack is equal to empty I'll take. So we have an empty stack. Pretty good. Fine. Now for num in nums2. So the second nums I am taking, that is we are first going with 6. Okay. While stack is not empty and whatever num I had is greater than stack of minus 1. Now, sir, what are you doing here? You see, since they have mentioned I need to go with the next greater element. Okay. I'm just simply going with the order of the biggest elements there. Okay. You will understand. Let's continue with this. So you see stack is empty. So I'll not be able to get into the while loop here. So stack is empty here. So empty, that's why I have to come out of the while loop. I just need to simply append this 6 into it. Done. I've appended it. Now again, for num in nums2, okay, I've accessed 6, so I'm accessing 5 this time. Now we are checking if stack is empty. No, stack is not empty. We have 6 inside of it. Okay. Now, is num greater than stack of minus 1? Okay. What is num? Num is 5. 5 is greater than 6. No, it's not greater than 6. So it's false. So again, we'll not get into while loop. Again, we will be appending that into 5. Done. Next. You see what happened? Sorry, battery low. Just a second. Yeah, connected. Plugged in. Right. Now see, next value, I'm accessing 1. So 1 in nums2 is stack is empty. No, stack is not empty. We have 2 values already. And 1 we have is greater than stack of minus 1. No, 1 is not greater than 5. That's not true. So again, the condition is not true. So we will not be appending it. We will go with, we'll be going to append it. So 1, we will be appending it here. Perfect. Now again, next value 3. Is stack empty? No, stack is not empty. Is 3 greater than the topmost element inside your stack? Yes, 3 greater than 1, correct. For the first time, we are getting into the while loop. So what we are doing, previous equal to stack dot pop. Okay, so pop the previous value, that is 1, and next greater of previous is, means the next greater value after 1 will be 3. Okay, so you see I have mapped that key with the next greater element. Okay, and how many times I'm doing it? I'm going to do it only for one iteration. Okay, let me tell you. You see, we are just accessing everything one single time now. Let me complete, then you will understand monotonic stack and its definition. So now, for now, I hope this is fine, right? So again, I'll go back, I'll check if stack is empty. No, I'll check if the number I have in hand, that is 3, is greater than the topmost element. Is 3 greater than 5? No, 3 is not greater than 5. Okay, so what else we have to do? We need to append this element into the stack as well. So 3 is appended into the stack, done. Again, next element is 8. So I'll speed run it a little bit. So stack is not empty. So that is true. And num greater than stack of -1. Num is 8. 8 greater than 3. Yes, 8 is greater than 3. So the next greater element after 3 is 8. So I'm going to pop the last element that we have. Okay, that is going to stored in the previous. Done. Now next greater of previous, nothing but in my map after 3 I'll be having the next greater element as 8, so I'm adding it into my mapping. Done. Now I'll check if stack is empty. No, stack is not empty. What is the num we have? 8. Is 8 greater than 5? Yes, 8 is greater than 5. So what is the next greater element after 5 if you observe? Okay, check it out here. After 5, what is the next greater element? 8 only. After 6, what is the next greater element? 8 only. Okay. Next greater element after that particular number. Okay. So this is how stack is useful. As I said, stack is very important moving forward. So this is what I was talking about. Now, why do we have that much acceptance rate for this question? Because people are doing it in normal way without using stack. That's meant for a different purpose. Okay. Anyway, so 8 is greater than 5. So we will be popping out 5. Okay. This is our previous value. Next greater of previous, next greater of 5 is equal to 8. So we have the next greater elements for everything, 1, 3, and 5. Now continue. Now is your stack empty? No, my stack is not empty. Okay. Why I'm checking this condition every time? You see, inside the stack I'm popping. If the stack is not empty, then only I can pop something. So whenever you have pop, you need to keep this thing in your mind. You need to check the stack does not become empty. Okay. Now, what is the num that you have? Num you have is 8. Is 8 greater than 6? Yes. So the next greatest element after 6 is 8 only. So we will be popping 6. That is the previous element. Okay. Then we will be adding it into our stack. So after 6, we will be getting 8. Perfect. Perfect. Now we will again go back. We will check if stack is empty. Yes, it's empty. I don't have any other element to pop or check. So I just need to simply add this into my stack only. So 8 is added into the stack. Now, next element is 9 I'm accessing. Okay. Is the stack empty? No, it's not empty. So fine, we can go ahead with the while loop. What is the number we have? Number we have is 9. What is the topmost element of the stack? That is 8. Is 9 greater than 8? Yes, 9 is greater than 8. So pop 8, that will be your previous. Okay. Next greater of 8 will be 9. So next greater of 8 is 9. Now again, is your stack empty? Yes, my stack is empty. I cannot continue with while loop. So I'll come out of it. Okay. Now here, stack dot append of num. That is whatever 9 you had, append it. Now num in nums 2, we got 2. Okay. Is your stack empty? No. Okay. Is your num greater than stack of -1? No. 2 is not greater than 9, so that is also false. So you will come out of the loop, you will be appending 2 inside it. Okay. Now you see we have accessed each and every element, so we are not having any other elements. So what else you have to do? Whatever elements that you have in your stack, they do not have a next greater element. So you just need to keep them -1. So what we'll do, while stack is not empty, okay, I just need to pop the previous elements, that is 2 is the previous element, add the value as -1. Okay. Now while stack is not empty, okay, it's not empty, we have 9 in it, pop that 9, that will be your previous, popped it. Now what do we have to do? place it inside the stack, label it with -1. That's it. So you got a hash map of all the keys mapped with their next greatest value by using monotonic stack. Okay, monotonic means mono, self-increasing, like increasing or decreasing order, we will be storing it. Okay, I'll even search for the definition for you, just show it. Not such a big deal. So stack only, but we are handling everything a little bit different. Okay, now we are done with it. So stack is okay, not sorry, stack is empty, so we came out of it. Now coming to the result array, so we have answer array is equal to empty. Now take every single element in your nums1. So I have taken 6. What is the next greatest element of 6? You see it is mapped to 8. Okay, append that value here. So for 6 it is going to be 8. So 8 will be mapped to this particular value. Perfect. Now what about the next greatest element of 1? Next element is 1. What is the next greatest element of 1? Okay, you see 1, next greatest element of 1 is 3. So we are mapping that 3. Okay, now what about the next greatest element of okay, 9? Next greatest element of 9 is you see -1. We don't have anything after it, so -1 it is. Okay, what is the next greatest element of 3? Okay, you see 3 is mapped to 8. That is the next greatest element of it. So perfect, we are getting 8. Done. Now this is the final answer. This is what we have written in the beginning, I guess. So let's check it. Yeah, 8, 3, -1 and 8. You remember I've scribbled this one on the screen. That's it. That's about monotonic stack. I hope you understood. The animation was beautiful, I guess, right? Any doubt? And one more doubt if you have, you see, empty stack will be considered as false. Okay, in Python, you see, while stack means if it is empty, this will be equal to false. That's why. If it's not empty, it will be true. If it has any other value, it will be considered true. So if you are having that difficulty, okay, we generally write everything in shortcuts. Once you get familiar with the language, you will understand all the shortcuts and all. So that's it. So understood this one. Do you want me to show this again or everything is fine? I hope everything is clear. I went very smoothly throughout the entire question. Now, once we are done with all the elements inside your array, we will be getting the answer. So this is the output we'll get. Okay. Any doubt? Any doubt in this one? 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 Guys, I hope I'm audible. What happened? Yeah. Understood. Understood. It was fine, or you guys were facing any issues, or what happened? The response rate has dropped so much. Okay. Or are those animations boring you? Should I go directly with the coding part without any of the presentation? You like that part or with the presentation? Okay. Are these animations boring you? Are they taking a lot of time? If they are not useful, I'll stop them. I'll go with the normal coding part only with some scribbling on the screen. Okay, we'll do that. What do you say? Okay then. Okay. So why I'm showing you these animations, ultimately the baseline is animation, whatever I'm showing is nothing but the tracing. Tracing in the sense what happens in each and every line during the execution. Okay. So once you understand that, all these things will be easy only. Now why this got 75% acceptance rate? Let's do it in one more way, the normal way. Okay. So uh, we will access the element here. Let me try to do it with these list functions and all. So result is equal to empty. Now nums1 we have, right? So let's search for a maximum value after that location. So per element in nums1, we need to search for this element in nums2. Then we need to search for the next greater element after it. Okay. So first we need to come up with its index. So start index is equal to, okay, nums2 dot index of nums1, nums2 dot index of element. Okay, this is the starting index, and ending index we all know that is the length of it, so that's what. So max is equal to -1. The next greatest element is -1. So I'll be accessing all the other elements for index in range of, okay, what is the range? Start index to length of nums2. I'm searching for the next greater element of nums1 and nums2. I'm looking for its starting index, then I'm accessing all the elements after it. So if any other element in nums2, if nums2 of index is greater than the nums1, then I'll make that as my maximum value. So maximum is equal to, okay, nums2 of index. And once we got it, we should not continue, we should break. Okay, that's it. Only the next greater now. We should not go with the maximum of all values. We should break. Now, when we are out of it, we can simply add that into our result dot append of max. Now, once we are done with everything, we can happily return result. This is one more solution. This is the plain old algorithm that you all might have come up with. Okay, so let's run it. Let's see if there is anything. Okay, int object has no attribute index. Nums2 starting index is equal to, we have nums2 is a list, index of element only I'm giving, so by that error. Int object has no attribute. Nums2 is not an integer, na? Nums2 is a list. Nums2 dot index of element. Nums2 dot index of element. That should work. I don't know why it's not working. Mm-hmm. Int object, they are saying nums2 does have that attribute. I have spelt the things correctly only. Nums2, NUMS2 only it is. Can't figure out what went wrong here. Starting index of the element. Okay, do we have a method called index? Yes, we do have a method called index. Nums2 is an array only. NUMS2 only. Then what went wrong? You see, let's understand this. The correct usage of ChatGPT, you see, I have no clue about what it's trying to talk here, because in object has no attribute index, that's fine. Integers will not have any dot index methods out. But here nums2 is not an integer, nums2 is an array here, so I don't know what went wrong. So let's use ChatGPT for a good purpose. Okay, that's the error, and this is the code. Let's keep both of them. Let's ask it to be a coding mentor. Okay, done. It will automatically figure out what to do. It will tell us something. Let's use this. It's happening. Nums2 is not a list anymore. It has become an integer. Why will it become an integer? Okay. Max equal to nums2 is equal to index. Did I do something? No. Nums2 equal to What's the corrected code? Remove nums to equal to index. Where did I write nums to equal to index? Okay, sorry, my bad. See, here I made this mistake. Okay, this is what making it as integer. So here we have it. Okay, this is the error. So I figured it out now. We don't have an error here. It's giving us an error because of this line. So max is equal to nums2 of index. Okay, yeah. Yes. Okay, that's it. That's the error. Now it's corrected. Let's run it. Let's run it. Now it's fine. Let's submit it. Hopefully it's fine. We should not be getting any TLE, time limit exceeded. You see, all other guys, it got accepted. So for me also, it got accepted. So perfect. Done. 21.13% because it's not optimal. Okay. It's not optimal. You see 20 millisecond. Again, 18% only it is beating. Let's try it one more time. Okay, this is the last time. Let's try it one more time. It will not even go higher than that. Okay, maximum 30 maybe. Yeah, you see 22 millisecond. Now we have came up with one solution. Now what is the optimizer solution for these type of questions? Okay, in your exam, TCS NQT is just around the corner as well. Okay. You can get TLE as well, or this can not pass the hidden test cases. Okay, if they set a TLE at 20% or so. Now, the optimized way to solve it is by using stack. As you have guessed it correct, we have seen the solution as well. Now, what do we have to do? First, let us take a map. Okay, so next greater, we will say next greater is equal to, I'll take a dictionary, empty dictionary. Done. After taking this empty dictionary, I hope you all are visualizing. The animation was a bit long, so I wanted to go that long because I wanted you all to imagine. Okay, it should run in our brain. Once you have seen some samples of it, you should be able to easily visualize what happens in that code. So next greater is equal to open and close brackets we have done. Now what else? What else we have to do after it? We need to access each and every character, each and every number of nums2. Okay, for num in nums2, I'm accessing it. Okay, now let us also take a stack as well. Now stack is equal to empty. Stack is equal to empty. Now while I'll be writing it in a easy manner, while length of stack, okay, well, length of stack is not equal to 0. We don't even have to write it in this manner. You can simply leave it as stack. If it's empty, that's going to be false only. And what else we have? And the value that I am having in hand, that is number, is greater than stack of -1. Okay, if it is greater than the topmost element of my stack, I need to pop it. So previous is equal to stack dot pop. Okay, now I need to add it in my map. Next greater of previous is equal to num. That's it. That is the next greater element. We need to keep on doing this. When it fails, okay, when it fails, we need to append this value. We need to append this value inside the stack. So stack dot append push of num. That's it. That's it. First step is completed. Now this will keep on mapping everything. Everything will be fine, done. Now once we come out of it, there will be some stack elements which will not be mapped, which doesn't have a greater element after it. We need to pop all of them. We need to map them to -1. So while length of stack is not equal to 0, what do you have to do here? Okay, next greater of this popped value, stack dot pop. Okay, in my brain, I'm actually running that simulation, whatever you have seen. Now, currently, that topmost element of the stack popped out. Okay, it went into the mapping. It came up with an arrow. Arrow is equal to, I'll be adding -1. That's it. Okay, this has to keep on repeating until stack becomes empty. When the stack becomes empty, it's time for me to calculate the result. So result is equal to empty for element in, okay, nums1. Okay, I just need to go with result dot append of, okay, the equivalent value for this key inside my map. So here, next greater of ELE. That's it. I'll get everything. I just need to return this result. Now, once I do that, I'll run it. Then I'll submit it if there are no issues. You see, we can do everything in a single go. Ultimately, when you visualize how data structures are done, or in a way, you will be able to happily run it. You see, I didn't even have to, okay, by heart anything or remember anything. Everything goes in a process when you actually understand what happens inside the screen. Okay, we got 2 milliseconds earlier, now it's 4. As I said, this time complexity one will not be good as of now. Let's run it one more time. We'll obviously get 0 at some point, so don't matter. 1, 2, 3, 4, 5. Now 5 seconds done. Let's submit it once again. Let's see if it reduces it. Yeah, 0 millisecond. Now you might ask, sir, what is the difference, sir? How many times we are accessing here? Okay, you see, if you observe, we are accessing every element only once. Okay, here we are doing it for one time. Here we are doing it for one time. So it's gonna be linear, big O of n, big O of n, big O of 2n. We know coefficients we have to drop. This is linear. This is linear. We can simply conclude it in that way. Okay, that's how simple it is going to be. So since we stored everything inside of a mapping, so every time you try to access it, the operation is going to be one only. So that's a bigger advantage for us. So this is linear time complexity. You see, we also have follow-up question maybe. Yeah. You see, could you do this with nums1 dot length plus nums2 dot length? That's what I told you. Okay, we are accessing each and everything. So that is going to be big O of, okay, nums1 dot length. We are again big O of nums2 dot length. We are accessing everything again, adding that into our result. This is going to be again big O of nums2 dot length. Everything else is negligible. So that's it. We are doing it in linear. That's how we followed it up. We have seen two solutions. First solution is how others solve it. Second solution is the way it has to be solved. So take a screenshot of this one. I'll show you solution 1 as well. Okay. Take a screenshot of this one. Take a screenshot of this one. I'll show you the solution 1 as well. Take a screenshot of this one. Done. Took a screenshot. Fine. Now let me show you the previous submission as well before this. So I think this one, yeah, accepted 7 minutes ago. Okay. Yeah, maybe you can take a screenshot of both of them now. You see both the solutions. Okay. Left side solution is accessing everything again and again. It's gonna take a lot of time. Right side is the optimizer one by using stack. Okay. Left side is just a regular nested arrays that we have. Nested loop we have. Done. Took. Everything's fine. Everything's fine. Then you will get attendance. Why being so crazy about it? Okay. Done. Perfect. Right. So that's it. That's about this stack version. And this is what we call as monotonic stack. Let me show to you monotonic stack, let's say. Okay. Monotonic stack, you see, it's a specialized data structure that maintains an element either in strictly increasing or decreasing order. So whatever we did, we created a monotonic stack, monotonic, okay? Either strictly increasing or strictly decreasing. So that's what we did. So examples, next greater element, next smaller element, it works by popping elements that violate the order before pushing new ones, okay? That's how, and we will be using that map for complementing it. That's all we did. Done. That's it. That's about monotonic stack model as well. One question from it. You can also do similar questions. Maybe let me show you the next similar question. Next greater element 2 we have, next greater element 3 we have, daily temperatures we have, okay. So let's try to solve one of these questions. Maybe next greater element 2, I'll give that as an assignment for you. We will do daily temperatures one, okay. Given a circular integer array nums, okay, the next element of nums dot length minus 1 is 0. So it's a circular one, circular array. Once you cross the last value, you again need to come back from the starting index. Return the next greater number for every element in nums. The next greater number of x is the first generated number. So small twist here, without adding -1, you just need to again get started from the beginning. So you can take the code that we have done for next greater element 1, and then you can make some modifications in it. It will give you the next greater element 2 as well. Okay. So there you got your attendance link, so you can have peace with it. Now see, next greater element 2 is your homework. Try to complete next greater element 2. We will take daily temperatures. Okay, this is also another good question actually. So we will go through this. Okay. And this time I would like you to form a big paragraph. I'll give you the option to post it in the host and co-host. And do not ask me attendance link. You have it here. Okay. So what's the time now? Time is, I think it's 8:30 somewhere. Yeah, exactly 8:30. Let me give you 6 minutes for this. Okay. We have seen enough coding. So you should be able to come up with the solution. Now see daily temperatures. Timer has started. I'll help you understanding the question better. Question number 739 in lead code it is. Okay. Now given an array of integers, temperatures representing the daily temperatures, return an array answer such that answer of I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which this is possible, keep answer of I equal to 0 instead. Okay. So see, temperatures we have is this one. So how many days do we have to wait to get another warmer day after 73 degrees? Only one day. Next day is warmer. Now see this one. Okay. 75 we have. So 74 also we have 75. Now see 75. 1, 2, 3, 4. After 4 days, we are getting 76. Now for 69, so for 71, we have to wait 2 days. For 69, we have to wait 1 day. For 72, we have to wait 1 day. Okay. For 76, you see, if the answer is not possible, we need to keep it 0. For 76, we don't have any greater temperature day after it, so 0. 73, it's 0. That's it. So same goes for the other questions as well. Temperatures will be from 1 to 10 to the power of 5. So the input is going to be long. And the temperatures will be from 30 to 100. Nothing else after it. Acceptance rate is 68. Anything above 68 is gonna be easy for you to solve. Below 60, we have to spend good amount of time. Hint, you can also check if the temperature is say 70 today, then in the future warmer temperature would be 71, 72, etc. We could remember where all of them occur next. Similar questions also you can see next greater element 1 we have, online stock span we have. So that's it. Topics, array, stack, monotonic stack. So we have seen that. That's it. So that's it. Use monotonic stack to try and solve it. Think about it. Try to come up with a basic approach. You see, you have the attendance link here. Okay. You can happily click on it and all. Done. That's it. You still have 3 more minutes. Let me make it 4 minutes. Okay. Or let me make it, yeah, 4 minutes would be good. Yeah, let's start the timer. Yeah, try to come up with some sort of solution. You see, we solved the previous question in 4 minutes only. So I'm expecting you to solve this one as well. After checking that animation, we have written the code in 4 minutes actually. Right, so you have 3 more minutes. I want some sort of answer. I'll open it at the ending. And so any answers we got? No. Very good. Very good. We'll keep in track of the decreasing temp. Okay. Yes, 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 that's correct. Monotonic stack, that's what it is. Okay. Now try to form a small logic around it. Okay. Try to form a small logic around it. Okay. We still have 1 more minute, then we will see the solution for this. And I think this is going to be the last question that we are solving today. Okay. When you slowly get into DS, you see first question took us somewhere around 40-50 minutes or so. Second question also did the same time. So that's how much time it's gonna take when we solve it. Okay. Then, so still have 30-40 minutes, sorry, 30-40 seconds. Yeah, so what's the answer? Daily temperatures we have. Let me try to check if it's present in my drive. The daily, yeah, temperatures we have. Daily temperatures, let's download it. Perfect. Right, so timer is up, I guess. So did not receive much response, but anyway, you guys will slowly grow. This is your first time seeing very good. Create a loop of range step, then maybe we will use another while loop. Very good, Aditya. Correct. Perfect, perfect. Okay, perfect. Fine, so let's check it out. Last question for today. Let's go through it. Let's complete it. Then we will close it. And so daily temperatures. Then no, not implementation in Java. Okay, yeah, let's see the implementation in Python. Now see. Okay, let me keep this on top. So we have the same sample input array that we are having. Okay. Now n is equal to length of t. So what is the length of the array that we have? That is, we have 10 elements, 10 temperatures. Now I'll create an answer which is having all zeros as of now because I'll be updating it with the differences. Okay. Now take a empty stack. This is our empty stack. While I in range of n, okay, from 0 to length minus 1, right? This is the I value 0. Now, while stack is empty, yes, stack is empty, so I cannot get into the while loop. So I'll be appending this value. Okay, stack dot append of 0, right? Now again, for I in range of n, I think it did, yeah, it got stuck there. But anyway, I in range of n, I value is 1 now. Is your stack empty? No, stack is not empty. We have 0. Now, temperature of stack of -1, that is temperature of the 0th index that is present inside the stack is 75. 75 is less than T of I. Yes, 75 is less than 73 only. Okay, sorry, 75 is not less than 73. So we'll not execute anything. We will be again appending it here. Okay, so 0 we have, 1 we have. Next again, for I in range of, is your stack empty? No. Is T of stack of -1 means 73 that we are having is less than 74? Yes, 73 is less than 74. So now what do we have to do? Okay, we will pop that index. The index is 1. The first index that we are having, okay, what is the next greater value after it? What is the next greatest temperature? Where did we get it? We got it at index I. So what is the difference between I and IDX? 2 minus 1 if you do 1. So that's what we are going to do. So answer of IDX is equal to, okay, I minus IDX. That's it, simple. The difference between the indexes of the days that we have. So we got it. We got one answer. Now we'll keep on doing it for all the other elements as well. So let me speed run it a little bit. Is your stack empty? No, stack is not empty. So we will take the topmost element that we have. So what is the index? 0. What is the element present at index 0? 75. Now what is the element in my hand? That is 74. Is 75 less than 74? No. So we will not do anything. We will append this 74 into the stack. We are appending it index. So we have 0 and 2. Now again, we are accessing the next index, that is 3. Okay. Is your stack empty? No. So stack is not empty. Is the topmost element, that is 74, is less than 71 that I am accessing? No, not less than. So while loop will not be true. Again, we are inserting that index. So 71 will be inserted. Now again, next value, we are getting 69. Is 69 less than 71 less than 69? No, insert 69. Okay. Again, 72 we are getting this time. Okay. Stack is not empty. 72 we are getting. Is 69 less than 72? Yes. So the next greater element for 69 is 72. So what is the index of 69? It is 4. So in the fourth index, I need to make that modification. So fourth index minus the current index, that is IDX is equal to 4. Okay. Now what is the difference between 5 and 4? That is 1. I minus IDX, that is going to be 5 minus 4, that is 1. So where should I update it? I have to update it in the index of that particular element. So IDX only. So I've updated it. Now again, stack is not empty. So if I pop the third element, 71 is less than 72. Again, 71's greatest element is going to be 72. So the index of 72 is 5. Index of 71 is 3. So 5 minus 3 is 2. The differences between those indexes is 2. I'll be updating it inside my array. Right? I hope you get the idea. We'll keep on doing this. Okay. You see, we have appended this one 5. Now we'll go with the next one. Sixth index I'm getting, and stack we have. It's not empty. 72 is less than 76. So pop it. The index is 5. So 6 minus 5. Difference is 1. Again, next element. 74 is less than 76. Pop it. Its index is 2. So 6 minus 2 is 4. So for the index 2, the next greater element you are going to get is after 4 indexes. You see, you can check 74 we have. We are getting 76 after 4 indexes, right? That's how it works. Now again, next element also 75. 75 is less than 76. So pop it. The differences between them is 6. We'll get it after 6 indexes. That's it. Stack is empty. Now we will append this particular 6th index that we have. Next again, 73 we got. 73 is not greater than it. So again, 73 is appended. 78 we have. Okay. 78 we have, and it is greater. So that's fine. 73 is less than 78. That's good. So we will have the difference between them. So 1 will be updated there. And again, Stack is not empty. We'll pop out the last value. 78 is greater than 76. We'll add the difference in that particular index as well. So that is also updated. Now stack is empty. So go ahead and add the 8th index. Now is your stack empty? No. Is 78 less than 70? No. So add your 70 as well. Done. Now we don't have any other elements to access it. So for loop will end. We will come out. We will return the answer. Since they wanted the default values to be 0, if there is no greater element, we don't have to access the stack again and make them as zeros. We have taken our initial array filled with zeros. So if there is a next greater temperature than it, we will have that appended. So this is what we are doing. Otherwise, we are not updating it. Okay. That's it. That's how simple it is. Now let's implement the same. So let's make it full screen. Let's make it full screen. Okay. Let's make it full screen. Done. Why you are crazy about attendance? You see, they are being posted multiple times by Amar sir. If you're not present in the first time when attendance link is being posted, you are just coming here for attendance. You see, earlier we had 225 people. After filling attendance, you guys are leaving. So, yeah, fine, you will get a certificate, but you will not get all these knowledge or so. Na? So, do not ask me about attendance. I'm very much anti to that word by now. Then, so what do we have to do? Take a stack. Monotonic stack we are going to do. Okay, so stack equal to empty. Now let's also create a result. Result is equal to 0 replicated with the length of the temperature. Since we are using it multiple times, let's take the length of temperatures. Okay. And one more thing, you see, I hate writing such big names, so I'll do one thing. Okay, I'll make it as t. In the function parameter, if you change the name, everywhere else you have to use the same name only. So that's how you can change it. So into n I'll do. So we are getting n number of elements. Now what do we have to do here? We just need to go with the indexes there. So for in range of n, I'm accessing each and every index. Now I need to check if the stack is empty. While length of stack is not equal to 0 and okay, so stack of -1, I'll be having the topmost element. In the temperatures, if that value is less than the current value that I am having, that current value means T of I. If it is less than it, then whatever you're doing, you just need to pop that value and add it into your arena. The difference we have to add it. So let's do that. So what do we have to do? We need to get that index. So idx is equal to stack.pop. So that index popped out. Now I need to find out the difference between I and idx. I minus idx. So I will be the biggest index. Idx will be the smallest index. This is the index I have. I just need to update it inside my result. Result of idx is equal to I minus idx. I found the element at index I which is greater than the value at idx. That's what we are doing. Okay. Once we are done with it, we will come out of the loop. We need to append this into our stack as well. So stack dot append of I. Okay, this index is also appended. Now that's fine. Now once we are done with everything, I don't think we need to do anything else. We just need to return our result. So that's all we have. Let's run it. Then we can submit it. Let's run it. Then we can submit it. Done. That's it. You see 113 millisecond, 35% it is fine. No issues. No issues. We'll submit it one more time. We might have a reduced time complexity as 44% it is. Let's try to submit it one more time. Still taking a lot of time it is. Fine, fine, fine. No issues. Okay. This is how to use monotonic stack. Okay. So I told you before, na. So in stack we will be talking about the standard ones. That is performing the basic operations in the stack. Okay. Push, pop, etc. and all. Expression evaluation in fix to postfix conversion, and along with that we have also seen monotonic stack as well. These are the important things for you to get started, and this is a medium level question with 68% acceptance rate, so you can take a screenshot of this one as well and try out this solution. Okay, so any doubts till this point? Any doubts till this point? I've enabled meeting group chat, so any doubts till this point? Any doubts till this point? Any doubts till this point? Done. Okay. Right. So your assignments are what else you can go through to complete this is. You see, online stock span is also a similar question. Next greater element 2 is also a similar question. Okay. So online stock span we have. Okay. So you can go ahead with this one. This is also 68% acceptance rate. Very easy. Okay. Labeled as medium, but once you get to know that concept, everything will become easy only. Done. But you need to know a bit of implementation of class and object. So if you know that, so you can happily go ahead with this one. This is one thing. And next creator element 2. Okay, we have already seen it with a small twist. You will be able to go through that thing as well, right? Those are your assignment questions to complete everything in this one. Done. Right. That's it. That's it about stacks. You see, we have 3 more lectures. Okay, Wednesday, Thursday, and Friday. So Wednesday we will be talking about queues. We will go through the implementation of queue. We don't have any actual programming questions much on queues. It's very basic data structure. So I'll see if there is any 1-2 questions that we can discuss. We'll come across it. Then we have basic of tree graph, I think. So my advice is I want you to go through pre-quest for that. You still have 1 more day before that session. So today also you have it. So go through basics of graph, basics of tree. Once you complete them, that will be easy for us to proceed with our general lecture. You can open any online blog, you can study it, or you can even go through a small 10 minutes introduction video about trees and graphs. Since we have a lot of beginners here, you can happily go through that. Last day, we are actually planning for dynamic programming. So on Friday, we'll be giving you a very good idea about dynamic programming. Okay. May not be enough, but 2 hours will give you a good idea about it. So that's what I wanted to tell about it. So tomorrow and after tomorrow, we'll quickly go through graphs and trees. We will go through the basic implementations in order, pre-order, post-order. So recursion, I want you to revise recursion once and go through the terminologies, go through the theory part a little bit. We'll focus on the implementation, will not focus much on the theory part. That's what I wanted to convey here. Okay. That's it. That's your homework. So just check out the basic terminology, etc. and all. Okay. Before the next session, we will quickly go through Q. We'll quickly go through Q. So check the basic implementations. Right. So any doubts? Any other doubts in any of the other questions? Anything? Anything that you want to discuss about? Done then. So we have only 5 more minutes. I cannot discuss another question in this 5 minutes. So if you have any queries, I'll be happy to address. Otherwise, we will end it for today. We'll close it for today. Okay. There is no exam as per my knowledge. You just need to attend all the sessions. That's it. Okay. There is no exam as per my knowledge. So for other details, you can contact the admin. You can contact the number mentioned on the brochure. Yeah, everyday attendance. Na? Those who attend all 15 days, they will get the certificate, I guess. I don't know any of those details. I'm just telling you something I might have heard about. It may not be correct, so yeah, I'm only here to deliver the lecture. Okay, I don't know any of those details.
Yes, I will clear it, sir. So guys,
Yeah,
60%
sure, sir.
attendance is mandatory to certification. I hope those who attended the day one, they have idea on this.
Done. That's it for today. Okay. Do have recursion basics. Do go through the basic terminology of graph entry. We are planning dynamic programming on last day, so if it gets delayed for tomorrow and day after tomorrow, we may need to drop that topic. Up to tree and graph, we would have completed everything full-fledged. Okay. That's it. So prefer any project to prepare for beginner. If you are a complete beginner, develop a snake game using object-oriented programming. Okay. Or if you want in web development, create a single page, okay, landing page portfolio site, okay, into web development. Done. Web development, landing page, portfolio project, HTML, CSS, JS will do basics of them. If you want it in object-oriented programming, data structures only it is going to be. So you can go with Snake Game. Very good project for a beginner. Snake Game. In Python, you can use TK inter module to create a snake game. You can search in YouTube as well. You will get a lot of references. You can build it in 1-2 hours. Okay. Will be very good as well. So let me show you one of the games that I have created. I generally make my students, okay. I teach through games, I teach through animation. That's how I am. So let me see, where is this? Yeah, this one, I guess. So this is one that we have developed for my students. So let me run this. Snake game only. If you are a beginner, I would suggest you to build the snake game. Okay. Yeah, this is the snake game. So you will get a good animation as well. And if you hit a wall, it is game over for you. That's another animation again. Let's run it one more time. You see 3, 2, 1 you are getting. Okay. If you eat that, okay. You can also make it circular. If you eat the food item, it will again respawn. It will be randomly coming up in any of these row column values. And if you touch it, this is an array. The snake is an array. We are incrementing the values of it. The background is actually black. So what we are doing is we are just highlighting that single element of the row and column there. So what it will look like is it's giving us an illusion that it is moving. So simply if I have to tell about this one, it's just a 2D array. 2D array with everything highlighted as black, and whenever you want to have your snake, you will make that as green. That's it. So I'll hit a wall. Okay, game over. Final score is 13. So if you are a beginner, go with this one. Okay, that's it. Done. That's it for today. I'll see you tomorrow. No, second year student cannot apply. That is only for 24, 25, 26 passed out. Okay. So 24, 25, 26 passed out. If you are a graduate of 24, 25, 26, then you can apply for it. Otherwise, no. Okay. That's it. I hope I have addressed all your queries. I'll see you tomorrow with queues and trees. Okay. I'll see you tomorrow. Tomorrow will be interesting. Tomorrow will be very easy as well in trees. So yeah, we'll get to that point. That's it for today. Bye bye. I'll see you tomorrow. It's 9 o'clock.